Alright, what's up, Trey? This is a video in reference to that challenge that I gave you before about positioning or making a script that would position a part in a few distinct positions in your world. So this is kind of a cheat sheet video or like an answer reference video on how you could go about doing that. I'm going to show you what I would do if I were to attempt this challenge or practice it. So, or just most challenges or practice for that matter. The first thing I would do is go ahead and pop open this test tab right here, and we're going to open a simulation of our game. And we're not doing anything in reference to a player model, so we can just keep this on 0 players since we don't care about that, and just click start. So this way we can do anything to our uh, simulated game environment without it actually affecting and saving those changes. So, and you know that you're in a test window when you see this kind of green outline around your game world that kind of indicates that it's live. So, the first thing that we can notice here is when we open Workspace, this is the part that I'm going to be affecting. And you can see when I select it, we have our properties over here. And you can see it highlighted in the workspace, but you want to notice that the name of the part is actually the same as all of these other objects called part. And that's actually a problem because, as you can imagine, we're going to be searching for this object by its name in the workspace. And if there are multiple objects with the same name, the program is just basically going to pick one at random. It might pick like the very last instance of that part that was added or the very first one. I'm not sure, but the point is that you don't know which part it's going to pick. And even if you did, it would still be confusing because there's multiple of them. So every time that you're dealing with a specific object in your game, um, you want to make sure that it has a unique name that distinguishes it from every other object in its container. In this case, the container being workspace. And the same rule actually applies anywhere else with software, right? Like if you try to create a folder on your desktop named like test, um, then if you then create another folder on your desktop named test as well, it actually won't allow that. So it'll force you to change the name so that the operating system can distinguish from which folder it's going to be looking for in the future. So I'm going to go ahead and rename this part to test part so it has a unique name. And now we can get into coding it. So I'm going to go to the server script service here, open that, and you should see that there's this script called chat service runner. That's just something that was created by Roblox for the game simulation. You can go ahead and right click that and delete it if you want to. It's not, you don't need it at all. And then I'm going to right click and go to insert object and search up a script, insert that. And now we can get started. So and now we can get started. So the next thing I'm going to do is, again, we're going to select this part, and we're going to look at the properties window. So what we want to affect is the position of this part, right? We want it to be kind of teleporting all over the place. Um, and the way that we do that is we can, let's try and find out. So we look through the properties window, right? And we see this thing called position. And the position property is really useful mostly just for looking at, so, right? So that you know, you have a rough idea of, or an exact idea rather, of where something is in your world space, right? So as I move this part, you can see that the position property changes. Now, um, these properties in this property window they're the exact properties that we would change inside of our script. So I'm going to go ahead and start and make a reference to this test part that I have in the workspace. So I'm going to make a variable called test part, and I'm going to set that equal to workspace dot test part. So now whenever we reference this variable in our script, it's going to give us this object and all of the properties and functions and everything that come with it. So if I wanted to change the position of this part in a script, I could say test part dot, and you might think we could do dot position, since position is the name of the property. And we actually could do this. We could do this, except there's a huge problem with just setting the position property itself. And that problem is that the position property doesn't avoid, or setting the position property doesn't avoid obstructions. And what I mean by that is, say for example, that we try to position this part here to the same position as this red part. Well, you would think if we set this part's position to the exact position of this part, that they would just kind of be like, let me see if I can get a realistic result here. So if I set this part's position to this position, they would just kind of, are you kidding me? Why are collisions? Is this gonna, god damn it. Hold on, let me try anchoring these. There we go. So, you would think it would do this, right? Where it would just kind of like be in the exact same place. But setting the position property doesn't avoid obstructions, which means that if I did set this position to this position, the game would look for the closest, nearest spot that this part could be in where it's not intersecting with this red part, right? So like, and it usually favors the Y position. So it would try to like place this part on top of this red part instead of inside of it. And that might sound kind of useful, but actually that's most of the time that's not what we want. And even if that is what we wanted, we still wouldn't use position because we could easily accomplish this just as well just by setting this part's position to this red part and then raising it by whatever height we need it to. So we never use the position property to set the position. We can use the position property a lot when we're trying to read the position. So like if we wanted to know in our script what the part's position was, then we could say like print test part dot position, and that would give us the position of the part, and we could, you know, just, it would just be useful to be able to like read the position of the part. So instead of doing position, we're going to use what's called CFrame, which stands for coordinate frame, which again is like a fancier way of saying position, but the difference between CFrame and position is that CFrame deals not only with position, but also absolute position, which meaning that it won't avoid obstructions and it can be placed, you know, parts can intersect with other parts, and it deals with rotation. So we're not going to be getting into rotation in this video, but just know that whenever you're setting the position or changing the rotation of an object, you're going to be using CFrame. So CFrame is a very important concept to understand if you're going to be doing any kind of coding with objects. So I'm gonna, what am I gonna do? Go here. So it's test part dot, and then it's gonna be a capital CF, and you'll see that it starts to come up here, CFrame, test part dot CFrame. Now, so what are we setting it equal to, right? Because a CFrame has, for a position, has three numbers. It has the X coordinate, the Y coordinate, and the Z coordinate. So, how do we group those numbers together to make one CFrame value? Well, Roblox has a unique value object called cframe, right? So it's a global thing. So as soon as you start typing cf, cframe will also pop up again. And this is a library. So this is the cframe library in Roblox, which means that this cframe thing that I have right here is a table. It's a list of functions that we have access to. So as soon as I put dot here to try to index and find one of those functions, you can see these are all of the functions that we have available to us. And you can see kind of like as I click on these, we have a little description of what they do here. So in this purpose, what you're going to be using most of the time is new. So the new function just creates a new cframe. That's all it does. And it says it right here. Creates a blank identity cframe, which just means a blank cframe. Angles is what you would use for rotation. So it creates a rotated cframe from a unit. But we'll get into that later. So cframe.new. And then this new thing here is a function that's going to, you're going to pass 3 numbers to. Okay, you're going to pass, and it's in order. It's the x coordinate, the y coordinate, and the z coordinate. So if I click on this red part here, you can see that the position property, it might be kind of hard to see, but every number in between these commas represents the axis that it's on, or the coordinate that it's on. So we're just going to go ahead and expand this so we can see it easier. So the x is negative 32.5, the y is 4.494, and the z is 1.04. So for the x coordinate here, I'm going to copy this and put it into the x field, copy this, put it into the y field, and then copy this and put it into the z field. And now when we run this code, this is going to take test part, get its cframe, get its coordinate frame, and set it equal to a new coordinate frame of these coordinates right here. Okay, so this test part is now going to be set to this part's exact position. And so the way that we actually run this code, I don't think I actually ever talked about activating a script in Studio. If you click on the script object that you inserted, that's going to open the properties window for that script. And you can see right now the disabled property. This just means whether or not the script is currently active or inactive. So the disabled property is false or unchecked, meaning that it is in a running state. But every time we make changes to the script, that doesn't update live. So we have to click the disabled thing. So disable it and then re-enable it. And every time you disable a script and then re-enable it, that's going to rerun the entire program. So I just disabled it, and I'm going to enable it. So this code just ran, meaning that our test part should be inside of that red part. And you can see that that is exactly what we got. So this part's position was then set to exactly this red part's position. So that's a good start. So let's just go ahead and find some other positions that we can set this part to. How can we find other positions in our game world? Well, if we just move this part around, you know, we can find exactly where we want to place it just by looking at this position. So, say for example, I want it to teleport over here. Well, all I have to do is just take this position, just copy it, and then paste it in here. And you can see that you can actually just copy and paste from the position field itself, because the commas are also included there. So if I move this out of the way and then ran this again, you can see it's placing the part back where I just took that position from. So Yeah, now let's do multiple positions. So, for example, let's say that the part is going to uh, first teleport here, and then teleport over here, right? So now I'm going to copy this position, and actually I'm going to copy and paste this entire line of code, because we're going to be changing its position to this. Right, so this was the first position, this is the second position. Now if I ran this code, we actually wouldn't really see anything, because code runs so quickly that if you have a situation like this, where you're setting a property, and then just immediately setting it to something else afterwards, you're actually not going to see that transition. You're just going to see whatever property it was last set to. So the way that we can do that is by adding some delay in between these two property reassignments. So, and the way that we can do that is by using the wait function built into the Lua language by Roblox. So this is Roblox's own addition to the language. So we're going to say wait, and wait is a function, and the number that goes inside of the parentheses of this wait function is the number of seconds that you want your program to wait before moving on to the next line of code. And that could be 1 second, it could be 10 seconds, it could be 0.5 seconds. I think the minimum wait time is something like 0.03 seconds. Like that's the shortest you can wait before it caps at that point. But we'll get into those specifics later on. So let's just go ahead and make it wait half a second before moving. So as soon as I run this program, I'm actually going to go ahead and kind of window this script really quickly. Actually, you know what? No, we don't have to window it. We don't have to window it. I'm just going to close this script and click on it in the server script service so that we can see this change happen live. So first, I'm just going to place this somewhere random, and we should see that it immediately gets positioned here, and then it waits half a second, and it should get positioned here. So I'm going to click on script. We're going to check this and then uncheck it, and you can see that's exactly what we saw. So, and you can just keep on doing this. You know, you can make this wait 1 second, and let's try setting it to another position, like right here. Or, yeah, let's go ahead and let's do this several times. So I'm going to copy this line. Oops. I'm going to copy these lines multiple times. And, just kind of... Oh, shit. Ah, go away. Just copy some random positions here. So that should teleport over here. And teleport over here. Okay, and we have 1 second of delay between each one of these positionings. So I'm going to close this script. I'm going to go back here, run it again. See, it waits 1 second, positions it to all of those places that we just recorded, and then the script ends and it's done. So, that's how I would start off doing it. You could then incorporate a loop into this, like maybe you wanted this to continue happening, so you could say while true do, right? And I'm just going to select all of this and then indent it or tab it so that we can see that it's all underneath this loop, and then end the loop. And one important thing to note here real quick with loops, just kind of a side note, is that as soon as the last line of code in your loop runs, the program will immediately go back up here to the top of the loop and run the first line of code. If the condition is still true, obviously, which if we have true here, will always be true. So in this case, it's going to set test part's position to this, and then it's going to go up here and immediately set it to this. So you actually won't see the transition from here to here. So what we're going to do is just add, you can add another wait either right here at the end, or you could add the wait right here at the top. It doesn't matter, just something so that there's some delay between, between this line of code and this line of code. So I'm going to come down here and just do wait 1, and now we should see a 1 second transition between each one of those positions. So we're going to disable this and re-enable it, and run this, and you can see this is just going to keep going on forever and ever until we disable the script again. So if I disable this, that's just going to stop running the code. And yeah, so that's kind of how I would do it. I guess I could add a bonus feature, a bonus solution, I guess. A way that you could simplify this if you truly wanted to make these positions random without having to manually record these positions is you could say testpart.cframe is equal to cframe.new, and then instead of finding actual numbers manually, we could use another built-in function from the Lua environment called random. So if I type random, you can see that it's highlighted, meaning that it has a predefined purpose. And actually there's another random function that isn't just specific to Roblox, that is it's in the math library. So if you type math in any version of Lua, it'll probably have some syntax highlighting, because math is, again, it's a library, so it's a table of functions that are specifically math related. So if I do math dot, you can see we have all of these functions here that take a number and do something with it. And there's a function in the math library called random, and what this does is it just gives you a random number. So if I go in here, right, for the x-coordinate, I'm going to say I want my x-coordinate to be math.random, right? And passing a number to the random function is actually optional. If you don't pass a number to random, then it will just give you a decimal number between 0 and 1. If you do pass a number, like say 10, then this function will give you a random number between 1 and 10. So it's really extremely useful because, you know, every game has some degree of RNG in it. So you're always going to be using random when you're creating a game. So let's say that I want to set this part's position to a random x-coordinate that is between, let's say, yeah, between 1 and 20, and a random y-coordinate that is between 1 and 20, and a random z-coordinate that's between 1 and 20. And then, again, like I said before, we're going to want to wait 1 second. Another important thing to note, actually, is that, remember what I said about loops going back to the first line of code once it reaches the last line of code in the loop, right? So if I say while true do, and I have some kind of code in my loop, right? Well, what happens when the first line of code is also the last line of code? It just keeps doing this forever and ever, instantly, and that will actually crash your program, because it's trying to do this process over and over and over again instantaneously, and that is just going to overload the CPU with work, and either the program will crash, the application running the program will crash, or in the worst case scenario, your computer will crash. So Roblox is obviously very sandboxed and protected, as are most game engines, so you'll usually never have your computer crash. you'll only have a computer crash if, say for example, a program actually running in your operating system has some kind of infinite loop like that. Um, and that's almost never the case. So usually it's just the application that'll crash. But anyway, what I'm trying to say is, uh, every time you have an infinite loop like this, you just want to make sure that you have some delay in that loop because it's going to keep going forever and ever and ever again. So we're going to add that wait 1 in there still. So if I run this now, if I disable this and enable it, like that, you can see now it's being set to uh, positive positions between 0 and 20 on every single axis. So this is a truly random kind of teleporting of this object. And I think that's where I'm going to stop it. I apologize if my voice was kind of weird. I had kind of a weird allergic reaction recently. Um, but yeah, hope this helped. And yeah.